In this video, we're learning about Earth systems and energy flow, so we'll cover what Earth systems are and how they interact across space and time, the two main energy sources that drive all of Earth's processes, and finally, how energy flow and matter cycling create chemical and physical changes. Let's start by covering the Earth's four main systems, and then go over how they interact across different scales of space and time. Earth has four main systems: the atmosphere, which is the whole mass of air surrounding Earth, the hydrosphere, which is all the water on our planet, the geosphere, which includes all solid parts of the Earth made of rock and soil, and then the biosphere, which would be all the living things. These systems aren't totally separate though. Instead, they're constantly interacting with each other. As an example, when it rains, water, which is part of the hydrosphere, falls from the sky and soaks into the ground. So during this process, it's moving from the atmosphere and into the geosphere. Plants would then absorb the water from the soil, and so the water would have then moved into the biosphere. Sometime later, the plants would then release that same water into the air as water vapor, and so the water would have been returned back to the atmosphere. It's important to understand, though, that these interactions between the systems happen across a wide range of both space scales and also time scales. As an example of different space scales, at the microscopic scale, bacteria in the soil break down dead plant material. But then at the global scale, ocean currents transport heat around the entire planet. In terms of different time scales, lightning strikes take fractions of a second and transfer nitrogen from the air into the soil, while tectonic plates take billions of years to move, but in doing so reshape the Earth's surface. In fact, these interactions have been shaping our planet for over 4 billion years. Early volcanic activity released water vapor and carbon dioxide, which went on to form the first atmosphere and oceans. After that, basic organisms began to emerge, and then changed the atmospheric composition by producing oxygen through photosynthesis. In turn, this eventually created the conditions that allowed complex life to develop. These same processes continue on today, and will shape Earth's future as plate tectonics keep moving continents, the water cycle redistributes fresh water, and climate patterns change as atmospheric composition shifts. Next, let's look at the two main energy sources that drive all of the Earth's processes. Every single process on our planet is driven by energy from just two sources: the Sun and the Earth's hot interior, which we refer to as the Earth's internal energy. For the Sun's impact, solar energy heats the atmosphere and oceans, creating wind and ocean currents. As well as these though, it also powers the water cycle through evaporation and drives photosynthesis in plants. The Earth's internal energy comes from leftover heat from when the Earth first formed, and the ongoing radioactive decay of elements within the Earth. This energy powers a few different things: plate tectonics, volcanoes, earthquakes, and mountain building processes. The way matter moves through Earth's systems is a bit different though. Whilst energy flows through these systems in one direction, matter continuously cycles. The water cycle, as an example, moves water between atmosphere, oceans, and land. The carbon cycle, by comparison, moves carbon between the atmosphere, living things, and oceans through photosynthesis and respiration. These cycles, powered by the Sun and the Earth's internal energy, keep Earth systems functioning as one interconnected whole. Finally, let's see how energy flow and matter cycling create chemical and physical changes. If we start with physical changes, these change something's form, but importantly, do not change its chemical composition. For example, in the water cycle, when solar energy evaporates ocean water, it's still water, so molecules of H2O, but just in gas form instead of a liquid. Similarly, during erosion, when flowing water breaks rocks into smaller pieces, the rock's composition stays the same, it's just its form that's changed. Chemical changes, by comparison, create new substances with different properties. For instance, oxidation happens when iron in rocks reacts with oxygen to form rust, which is a completely different chemical substance from iron. During photosynthesis, plants use solar energy to combine carbon dioxide and water into glucose and oxygen, so entirely different substances. Similarly, cellular respiration is a process in living organisms that cause glucose to break down into different substances like carbon dioxide and water, and in doing so releases energy for life processes. Heat from Earth's interior also causes both physical and chemical changes. An example of a physical change caused by this heat is when it melts rock into magma. And when this magma cools at the surface, that is another physical change, as it solidifies back into igneous rock. It keeps the same chemical composition, and just changes between liquid and solid forms. On the other hand, the Earth's internal heat can cause chemical changes too, like when these high pressures and temperatures transform non-metamorphic rocks into metamorphic rocks, with different mineral compositions.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.